So if you're learning about virtual machines for the very first time, it can be a little bit intimidating. However, if you already have basic knowledge of how computer components work, then you already know more than you think. So let's talk about what virtual machines are. Well, I'm going to start off by bringing up why we actually need them. So let's just say you have your physical computer. This is going to be your hypothetical physical computer. It has 8 cores on the CPU, 16 gigabytes on the RAM, 1.5 terabytes of storage, and on the storage we have Windows 11 operating system. This arrow indicates that the operating system gets moved into the RAM, and of course the CPU communicates with the RAM. And any more data that's needed from the storage will get loaded in as needed. So even though Windows 11 is great for certain tasks, you may be a computer forensic investigator or you may be a penetration tester and you might want to use Kali Linux. Now, you could set up a dual boot system, so every time you turn on the computer, your physical machine is then dedicated to the Linux system as it's after booting it up. But if you want to go back into Windows, you have to restart it and reboot it again. If you want to go back into Linux, you have to reboot that again. So basically, it's very inefficient, it's very time inefficient, and it's not good for productivity. So the solution there is to create a virtual machine. So, unlike a physical machine, it's a virtual machine. Okay, but seriously speaking, what that means is basically you have a computer running on the Windows operating system as if it were an app, basically, and you actually dedicate portions of your resources to maintaining this operating system. So, for example, if I were to set up a virtual machine right now, then I might dedicate 6 gigabytes of the RAM to the Linux machine. So that would mean 6 goes to Linux. I'm just going to say Lin. And that would leave us with 10 gigabytes for Win. On storage, it actually, with Oracle VirtualBox, it actually gets stored in a folder. So I could have maybe 500 gigabytes dedicated to Linux. So that's 5, actually hold on, I'm just gonna, for illustration purposes. So that's 500 gigabytes for Lin. And that will leave us with 1 terabyte for Win. And as for cores, it's the exact same thing. You might, good to know. For cores, it's the exact same thing. So you might divide that up into 4 cores. So basically 4 for Win, and 4 for Linux. That's great and all. So you may actually be asking yourselves, what would happen if I were to give perhaps 10 gigabytes of RAM to the Linux machine and I gave 6 to the Windows machine? Or maybe I could give the majority of the cores to the Linux machine. And maybe the storage, well, that's theoretically impossible unless I have tried this actually. But anyway, what will happen is you can actually starve your machine. Okay, like I said, Windows is the host. Linux is only the virtual machine running on the Windows 11 host. So what will happen is, if there aren't enough cores to maintain Windows, or if there isn't enough memory to maintain Windows, then what will end up happening is your computer will actually restart. So basically, you won't win, you lose either way. So if you don't have a lot of resources on your computer, then unfortunately you'll just have to opt for a slower running virtual machine. Either that or get better resources. Because if the machine starves, then of course it's just going to be tedious. So basically, to summarize, a virtual machine is a computer within a physical computer that is created through dividing the resources of the physical computer to allow the virtual machine to run on the host operating system. And I repeat one more time. Linux is the virtual machine running on Windows, which is the host operating system. And of course, these are the specs that we've allocated as we've just discussed. So with that in mind, remember earlier on how I said that if you understand how the components of a physical computer work, you pretty much understand how a virtual machine works. It is essentially building a computer again. You put in your cores, you put basically your CPU, you put in your RAM, you put in your storage, and then your computer ideally boots the operating system. So it's exactly the same thing, same process basically. But this is the part where it gets tricky. By the way, this is not a tutorial on setting up Oracle VM. This is only to help you understand virtual machines and how they work. So this is a Kali Linux machine that I have set up on my computer. The specs are not going to be the same as our example because this is my computer. Okay, so here's the system. So on our motherboard, I have allocated 700 megabytes, that's 7 gigabytes of memory to this virtual machine. 7 gigabytes out of the 32 that I actually have on my physical machine. So when I built this computer, I put in 32 gigabytes of RAM. But when I set up my virtual machine, I have allocated 7 gigabytes. So every time I power this up, 7 gigabytes are going to be taken away and they're going to be allocated to the virtual machine. So essentially, every time I spin this up, I basically have 25 gigabytes available on my host machine. And now we're going to look at the processors. Now, as I said, if I didn't mention this, threads are not important. What we're worried about are the cores. So my CPU has 24 individual cores on the chip, and I have decided to allocate five cores out of those 24 cores. So basically, every time I start this up, my physical machine is going to have 19 cores to play around with. Now, something to bear in mind is that if you have too many cores, okay, so let's just say I have 7 gigabytes of RAM. If I were to put in 7 cores, this would actually slow the machine down. You might think it would make it quicker. Sure, plenty of RAM, plenty of cores on top of that, but unfortunately what happens is the key of thumb, the rule of thumb here is 2 gigabytes of RAM per each core. Okay, I'm kind of breaking rules here, but it works. Okay, so basically if I were to allocate 7 cores, it'll slow the machine down because the cores will be competing for resources. They will be competing for RAM slots, so it's actually counterproductive. This right here, the video memory, this is the amount of memory that you're going to allocate in order to put the graphics up onto the screen. I set 36 megabytes. One thing to bear in mind about Kali Linux is it's not a very intense operating system. A lot of the Linux distributions are not actually. So that's why I haven't given it any over-the-top specs. And this is our storage. So just to show you how storage is made actually. So we'll just go create. So we're going to go with create a virtual hard disk. So essentially it's a hard disk, only it's completely computerized. Okay. So out of the 2 terabytes that I have available, I could allocate maybe 26, 31, 32, or 80 or 90. Yeah, it's all up to me. And of course this disk given the extension file VHD. And this can be booted onto other virtual machines if you wish it. So like I said, these are essentially, if you look where my mouse is, these are essentially computers, 2 individual computers with 2 individual specs. I could move my VHD disk onto this one and it should ideally boot up the exact same way, boot up the operating system. Just like in real life, if you have two computers, you take out the storage with an operating system on it, you put it into a new computer, it should boot right up. Just for the record, if you're paying attention to my VDI, the only reason I picked the VDI is because I'm just more familiar with it, and it's just easy because I don't really plan on having a virtual hard disk. I won't get into what that is, but it's only just for illustrative purposes and just to explain, just in case anybody is thrown off by it. Of course, here you have your audio, you have the audio controller. Then you have your network adapter. So basically, it's essentially putting ports, network ports, into the computer. So right here, this is actually for my wireless internet. And over here, this is actually a port for Ethernet. So if I plug in Ethernet, it's going to know, oh, okay, this person has to plug it in Ethernet, and it'll understand it. And the same goes for the wireless LAN card. If I didn't have these, or if I didn't have one of them, if I shut this off, then I wouldn't be able to connect wirelessly. And as for this, I would not be able to connect via Ethernet. The rest here are your ports. Okay, so you basically put in the ports, you put in your USB ports, and your shared folders, which once again, I'm not going to get into. Okay, so I've shown you what exactly makes a virtual machine. I hope you have a better understanding of it. Now I'm going to go ahead and boot one up. I'm going to boot up my Linux machine. And so one thing to pay attention to is my host machine, that will be Windows 11. So basically, the operating system that's on my SSD is Windows 11. And on Windows, now via Windows 11, I'm running Oracle VM, and now I'm going to start up the virtual machine. So essentially, what happens now is this sandbox is created, this computer is created, and it's got, if you pay attention to my mouse, 7 gigabytes of RAM, that's after being used up now, 5 logical processors, that's after being used up now, 36 megabytes of video memory, that's now used up, and of course the storage, which it's been saved onto. Okay, so let's discuss why virtual machines are effective. Well, as I said earlier on, they're great for productivity, okay? It is better than booting it up over and over again on a dual boot machine. However, if you don't have a very good PC, then it may be the option that you have if it runs too slow on your computer, if it runs too slow on as a VM. However, it will be tedious. Interestingly enough, in cybersecurity, it's a good way to check files. So let's just say you receive an email, you're not quite sure about it, you think that there might be a virus, or if it's telling you to run something, you think, well, this might be a virus, this could completely damage my machine, it could be ransomware. A good place to test it out would be a virtual machine. When you run it on the virtual machine, if it is a virus, it will only damage the virtual machine. You better make sure that the virtual machine doesn't have any sensitive data on it, but it's just good for testing these files. Because it's a sandbox, it's not going to jump out onto the host machine, where you really don't want a virus. I do have to warn you that through very, 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 very sophisticated attacks, it is actually possible to attack a computer at the kernel level so that it actually breaches the hypervisor. The hypervisor essentially is an interface between the CPU and the operating system, which actually manages the division of the resources. Now, of course, nothing is ever completely secure, so if somebody does find an exploit to the kernel or to the hypervisor, then of course maybe they can do damage that way. So it is important to bear that in mind. However, it's very difficult to pull off, so you should be safe. Anyway, that's really all that I have to share with you in regards to understanding how virtual machines work. I really hope this helped, and if there was anything that you were confused by, or if I made any mistakes, please let me know in the comments. I would absolutely appreciate it. Anyway, thank you very much for watching, see you and goodbye.